Alright guys, welcome back to another LeetCode tutorial. So today's problem is called +1 and it's a part of the July challenge. So our problem description is, given a non-empty array of digits representing a non-negative integer, essentially what we want to do is just add 1 to the integer. So the digits are stored such that the most significant digit is at the head of the list, and each element in the array contains a single digit. And we can assume that the integer does not contain any leading zeros except the number 0 itself. So what do they mean? They mean, if we look at example 1, if we're given 123, if we add 1 to 123, we would get 124. And since each slot in the array represents a digit, we know that we have to go to the least significant digit and essentially just add a 1 to it. So if we look at example 2, essentially this number is 4,321, but it's just broken up into separate digits. But we would just want to still add 1 to it, and so our output would be 4,322. So at first the problem seems kind of not too bad, pretty straightforward, but we kind of have to think about some edge cases here. So let's say I were to give you the array 999, and again we'd have to break it up into its digits. So what would we return here? Essentially we already know, like, if we add 1 to 999 we want 1,000, right? So we would just write 1,000 and this is what we would return. But hopefully you notice that, like, this new array is bigger than our previous one. So in case 1, if we're given like an array consisting of all 9s, we know that we have to essentially create an array of size n+1, and then from there we would just make the first digit a 1, and we would make all the 9s zeros. And when we look at the code, that'll be more clear, but for now think of that as case 1. Again, if I made this like 99, we know we want to return 100. And again, in this example, you can see, like, each of the 9s becomes a 0, and then we would just append a 1 to the front, pretty much. And now we can think about case 2 here. So for case 2, let's say I gave you like maybe 6,999, and again in this case, do we need to make an extra slot? And the answer is no. So we need to make sure that we only create that extra slot if the array is all 9s, because as you can see, we actually want to return 7,000. So in case 2 here, we'd still make each of the 9s a 0, but rather than the first element being a 1, we would actually add 1 to our previous element here. So we can kind of think of that as like case 2, and really case 3 would just be anything that doesn't have a 9 in it. So like these two examples up here, there's no 9s, so we don't really have to do anything special. We can just add a 1 to the last digit, pretty much. So we know how to do it. Let's get straight into the code, and hopefully it'll make more sense. So first things first, I'll leave those cases up there, but we want a quick way to access our size. So we can say n is digits.length, and so now that we have our length stored, let's begin our iteration. So the way we want to do this is we actually want to iterate backwards. It'll just make it a lot easier, because potentially, like, if we run into these two cases up here where all we have to do is just add a 1 to the last digit, it'll be very easy to do that. So we're going to start at the end. So I is going to start off at n-1 as long as I is greater than or equal to 0, and we're just going to continue decrementing. So first things first, let's take care of the case where there's like no 9s. So if there's no 9s, it's pretty simple. So if digits at, sorry about that. Essentially, if digits at I is not a 9, we can literally just say digits at I plus plus, just add a 1 to it, and then we can just return digits like that. And if you think about it, this will actually take care of case 2 here as well, because if we continue to iterate through this and we really only care if it's not a 9, essentially by the end of it we would make this a 7, and as you'll see later on, we'll also handle the case where we do see a 9, in which we would make it just all zeros pretty much. So that might be a little confusing now, but essentially this is what I'm saying. So if we see a 9, we're just going to make it a 0. So we've now handled case 2 and the case where there's like no 9s at all. So if you look back at this example, every time we see a 9, make it a 0, but if we don't see a 9, just literally add 1 to it and return our array. So this is fine, but it doesn't address case 1 here. So case 1, again, a little less intuitive, but really what we want to do is make a new array. We can just call it literally new array. So new integer array, and it's going to be of size digits. I can just say n plus 1 since we created n up there. So it's going to be of size n plus 1 because we have to accommodate for that extra spot. And essentially all we're really going to do is say new array at 0 equals 1. So not too bad. And the reason for that is because, like, if you saw in the case where we had 99, we make that extra slot for dedicated to that 1, and the rest would just be zeros. And after we do that, we can just return our new array. And again, all of this would only happen if the array is all 9s pretty much. So let's just run this to make sure we're all good. Looks good so far. Let's go ahead and submit. And we're good. So yeah guys, that's how we solve +1. Hope the explanation was clear and intuitive. And I hope you guys enjoyed the video. I'll see you in the next one.